Welcome guys, welcome once more to my channel. Today I'll be talking about differentiation. Differentiation is a branch of mathematics that is largely established by Leibniz and Isaac Newton. The concept of differentiation teaches how to find the gradient of a curve. It's very important to find. For the gradient of a straight line, it's very easy. The gradient of a straight line is the increase in x by increase in y, the increase in y over increase in x. Let's say we have the gradient. Let me look for the gradient of a curve, a gradient of a straight line, the gradient of a straight line, which is like, let's say we have our, let's say this place is point, let's say this place is point P, and this place is point Q. Then we have our 4 and 16, and 3 and 9. For the gradient of the gradient, which is represented like as n, we have our increase in y over increase in x. Then for an increase in y, it means that our y2 minus y1 and our x2 minus x1. Then it will be y1 y2 minus y1 over x2 minus x1. Then it will be n is equals to our y2 is this, so we put 16 minus y1 9 over x2 4 minus x is 3. Then we have 7 over 1, which is 7. For the gradient of a straight line, this is very easy. So when you are looking at the gradient of a curve, that you can't easily determine using the gradient formula. So we're going to look for the gradient function, which we will apply what we call differentiation. So in differentiation, let's say we have the curve y is equal to x squared, y is equal to x squared, y is equal to x squared. For this curve, for the curve like this, for us to look at the pattern, let's say as our gradient was at x is equal to 1. For me to look for the gradient of the tangent of this curve, I know a tangent to tangent line that just touches the circle at the same point. Let's say our distance must touch each other. This line is my tangent. So for me to look at the tangent, the gradient of the tangent at this curve is very difficult for me to look at it. So if I'm not to look at it now, I can't apply this formula because it is a curve, it's not a straight line. So what I'm going to apply is that I will apply the first principle. For me to do that, the first principle, let's say I have, for this curve, I have y is equal to x squared. For me to differentiate this, I will apply the first principle formula. And let me replace our y with y plus increase in y is equals to. If I replace my y to be like this, that means that my x will also be like this. So I have x plus increment in x should be x squared. Now this, for me to expand this, it's very easy. I'll just say x squared plus 2x increment in x plus increment in x all squared. And now I have my y plus increment in y. Seeing this now, this is just the first stage. Then I'll have to carry this minus this y to this other side. So I'll have my increment in y to be x squared plus 2x increment in x plus increment in x squared minus y. I know that I'm carrying our y here, but what is the value of our y is x squared. So meaning that instead of, I don't say increment in y is equal to x squared plus 2x increment in x plus increment in x all squared. What is our y? Our y is x2 from the question. x2. Then x2 minus x2. Then x2 will be 1. Then come to this, and I'll divide this increment y over increment in x, then I will have 2x increment in x plus increment in x all squared. And remember that I divided the increment in y by increment in x, and I will have increment in x over increment in x. Then this now will be our 2x plus increment in x. Remember that this one is x squared and this one is increment in x. If I cancel one out of this increment in x, it will remain only one. Then we'll take the limit of this guy. So to the limit of this function when our increment in x approaches 0. But when I say something approaches 0, it's not exactly at 0 point. It's just approaching the 0 point. Let's say I have the number. Let's say I have the number 0.1. Yeah. Let's say I have the 0.1 like this or 2. This is not a 0. It's just approaching 0. But so when I say something approaching 0, it does not mean that it's exactly at 0 point. It's just approaching it. Then if I take the limit of the function when increment in x is 0, means that I will now have only 2x left. This will be gone. So I will say my limit of the function of increment in y over increment in x is increment in x approaches is 2x. So having seen this now, I will have our increment in x to be 2x. Let me clean this. For me to look at target as x is equals to 1, I will just say on my dy dx when x is 1, it will be 2, 1, which is 2. So this is an alternative method for me to look at the gradient of this curve at this point, because I can't look for it since it's a curve, and know a curve is usually raised to the power of 2, which is a quadratic equation. So I'll be saying this now. I would love us to go into what we call the product rule. The product rule. This with two. So now looking at the product rule. The product rule is with two functions. Let's say I have my y to be y is equals to x squared and x plus 1. For me to differentiate this, I will apply what we call the product rule. The product rule states that my dy dx will be u dv dx plus v du dx. So meaning that what I'm going to do is that I'll pick this to be my u and this to my v. So let's say I'll substitute, I'll say u is equals to x squared and my v should be x plus 1. So having saying this now, let's differentiate our du dx. Our du dx is 2x and my dv dx is 1. Because if we are looking at the differentiation of any expression, we assume every number is a constant, and the differentiation of any constant is 0. So 1 here does not carry s, meaning that the differentiation of 1 here is a constant, which is 0. So having said this, now let's just fix it into the formula. Our dx will be u. Our u is x squared. Then the v dx, which is 1, times 1 plus v. My v is x plus 1, and u dx is minus 2x. So then my dy dx will be x squared plus let me expand this. I have my 2x squared plus 1. So since this and this is likeness, I will just say I have my 3x squared plus 1. So this is called a product rule. So I would like to go into my quotient rule. So I will just introduce the quotient rule. The quotient rule is just the quotient rule. Let's say I have an expression x squared over x3 x3 plus 1 x3 plus 1. So seeing this, we will just apply the quotient rule since it's division. Yeah. So the quotient rule is dy dx is equals to v dx minus v dx over v squared. So this will be my u and my v. So I have my u should be x squared and my v should be x is power 3 plus 1. So let me differentiate du dx, which is du over dx is equals to 2x, and dv dx should be 3x squared. So our v squared, our v squared will be x3 plus 1 all squared. So I'll just fix this all into this expression here. Then I'll have dy dx to be, my v is what? My v is x3 plus 1. I'll have x3 plus 1. And my du dx, which is this, times 2x minus, then I'll put my u. My u is x squared. And my dv dx, is times 3x squared over v squared is x3 plus 1 whole squared. So to be dy dx is equals to x. Let me just expand brackets. I will have 2x is to the power 4 plus 2x minus 3x is to the power 4 over x3 plus 1 is to the power 4. And this will give me 2x4 minus 3x4. Since it's like terms, we bring them together. Then we have my minus x4 plus 2x all over x3 plus 1 is to the power 4. Then our dy dx is this. So having seen this now, I would like to this is the end of the quotient rule formula, which is this. Then our product rule formula, which is this. So watch out for differentiation 2. Kindly subscribe to my channel to see more. So now we're looking at the product rule. The product rule is with two functions. Let's say I have my y to be y is equals to x squared and x plus 1. For me to differentiate this, I will apply what we call the product rule. The product rule states that my dy dx will be u dv dx plus v du dx. So meaning that what I'm going to do is that I'll pick this to be my u and this to my v. So let's say I will substitute, I'll say u is equals to x squared and my v should be x plus 1. So having saying this now, let's differentiate our du dx. Our du dx is 2x and my dv dx is 1. Because if we are looking at the differentiation of any expression, we assume every number is a constant, and the differentiation of any constant is 0. So 1 here does not carry s, meaning that the differentiation of 1 here is a constant, which is 0. So having said this, now let's just fix it into the formula. Our dx will be u. Our u is x squared. Then the v dx, which is 1 times 1 plus v. My v is x plus 1, and u dx that is minus 2x. So then my dy dx will be x plus, let me expand this. I'll have my 2x squared plus 1. So since this and this is likeness, I will just say I have my 3x squared plus 1. So this is called a product rule. So I would like to go into my quotient rule. So I will just introduce the quotient rule. The quotient rule is just the quotient rule. Let's say I have an expression x squared over x3 x3 plus 1. So seeing this, we will just apply the quotient rule since it's division here. So the quotient rule is dy dx is equals to v dx minus v dx over v squared. So this will be my u and my v. So I have my u should be x squared and my v should be x is power 3 plus 1. So let me differentiate du dx, which is du over dx is equals to 2x, and dv dx should be 3x squared. So our v squared will be x3 plus 1 all squared. So I'll just fix this all into this expression here. Then I'll divide dx to be, my v is what? My v is x3 plus 1. I'll have x3 plus 1. And my du dx, which is this, times 2x minus, then I'll put my u. My u is x squared. And my dv dx is times 3x squared over v squared is x3 plus 1 whole squared. So to be dy dx is equals to x. Let me just expand the brackets. I will have 2x is to the power 4 plus 2x minus 3x is to the power 4 over x3 plus 1 is to the power 4. And this will give me 2x4 minus 3x4. Since it's like terms, we bring them together. Then we have my minus x4 plus 2x all over x3 plus 1 is to the power 4. Then our divide dx is this. So having seen this now, I would like to this is the end of the quotient rule formula, which is this. Then our product rule formula, which is this. So watch out for differentiation 2. Kindly subscribe to my channel to see more videos.